Hi, let's talk about when to use shells and when to use cross-sections when you're finding the volume of a volume of revolution. So here I've got two examples that are very similar. In both cases, we're taking the area contained between two curves and we're rotating it around the y-axis. Generally, I think it's easier for students in my experience to think about these problems in terms of cross-sections. Shells feels very unfamiliar to most people. So I'd say unless there's a compelling reason not to use cross-sections, you should probably use cross-sections. Let's take a look at these two examples, and I think we'll encounter a situation where it's going to be easier to use shells. So in this problem, if you're imagining the cross-sections look like they're cutting across the y-axis, because that's the axis that we're rotating around. And it looks like the cross-sections are these kind of washer shapes, where the inner radius is determined by this function, and the outer radius is determined by that function. So the only tricky part about this is we're integrating starting at y equals 0 up to this intersection point at, what is that, y equals 1? So if I was going to construct an integral, it would be, from 0 to 1, and it's something dy. So I would need to rewrite these two equations, which give y values in terms of x values, so that instead I'm getting x values in terms of the height that I'm at. So let's go ahead and see what that looks like. So if I'm going to rewrite this, I had y equals root x, so instead I'm going to rewrite it as x equals y squared. So that's going to give me my inner radius. For this one, I've got y equals x cubed. Let's rewrite it as x equals cube root y. And that's going to give me my outer radius. So if you remember, the area of this kind of washer shape is pi times the large radius squared minus the small radius squared. So that's what I want to apply in here. So I've got pi times, let's see, my big radius squared was determined by this function, which is cube root y. And then my inner radius is given by this function, which is y squared. And then y squared squared is y to the fourth. So that would be a totally okay way to do cross-sections for this one. And the only thing that's tricky is you have to rewrite the equations so that you can get those radii, because they're dependent upon the height. Okay, well, I think if that feels awkward to you, I think shells are also a very clean way to do this same problem. So let's take a look and see what that looks like. So same problem. This is root x. This is x cubed. I am rotating around the y-axis. Let's pretend that that's symmetric. Oh, God. It's very ugly. Okay. So what would shells look like here? If I choose a particular distance out from the center, and I look at the area between the two curves, that gives me a height here. And if I rotate just that vertical bar around the axis of rotation, I get a shell that looks like that. If I were to choose further out like this, I would get another shell that looks like that. So if I'm going to be looking at the volume contained within just the walls of this kind of hollow shell, remember the shell volume equation that we had looked at in class was it's the circumference times the height times that infinitesimal thickness. So the circumference is going to be 2 pi r times the height times our infinitesimal thickness. So the radius here, the r for the radius, is the distance from my y-axis out to the point that I'm evaluating at. So that's the same as x. So 2 pi x. And then the height is just the difference between the y values at that x coordinate. So let's see, my upper curve is root x, so that's root x minus x cubed. So that's the height. X is the radius, and I've got dx. So now I'm going to integrate starting from, remember, x value is my radius, so I want to start right in the middle with a radius of 0 and go out to a radius of 1. So 0 to 1, 2 pi x times root x minus x cubed dx. And that would be a totally decent way to do it with shells. All right, so now we've got 2 of these under our belts. Let's look at this one. So what if I wanted to do this one using cross sections? What's awkward about this is here I've got in, for my washers, I've got an outer radius and an inner radius. So if I choose a y value that's high enough for this one, I've got like a very large inner radius and a somewhat larger outer radius. So it looks like that. But that's, if I find an equation for the area of that cross section, it doesn't apply all the way down this curve. Because once I hit here, once I hit that value, under here, there is no hole inside my cross section. It's just a perfectly circular disk. So it's not like you can't do it this way. You could. You would just have to split it into 2 parts. We would find the volume from y equals 0 up to this point, which is at y equals 1. And then we would have a separate integral for the volume from y equals 1 up to this value up here. So that's sort of like getting awkward enough. It's probably worth considering how to do this with shells instead. So let's do this one with shells. Again, let's pretend this doesn't look horrible. Okay, that seems like roughly the same. And so again, in this case, if we imagine some cylindrical shells, I've got my radius is given by x, and I've got the height as the difference between those 2 curves. So it's going to be 2 pi integral 0 to 1. Is it 1 out here where they intersect? No, it's not, is it? Is it 2? Yeah, it's 2. Okay, so from 0 to 2 of my radius times the height, and the height is going to be, what's my upper curve? My upper curve is 2 to the x. So 2 to the x minus x squared dx. And that's like very, very clean. Whereas if you were going to try and do this by cross sections, it would be a lot less clean. So stepping back, when do you use shells? When do you use cross sections? So I would say first draw your cross section and imagine it. And think about what information do you need to find the area of your cross section. You always need to be able to figure out what are those 2 radii. If you've got a problem where your cross-section significantly changes shape as you're moving along, that's a signal to you that you probably shouldn't be using cross-sections. You should probably find another approach. And again, it's not impossible. Like, oftentimes you can break the problem into pieces and that will still work. But it's a signal for you that you might want to back up and think, is there an easier way? I think that's all I have to say.